Welcome to the keynotes video for this week, and our thing that we're going to look at this week are basically precipitates. So our heading for this week is going to be precipitates. We're also going to look a little bit about balancing equations. And precipitates are solids that form when solutions are mixed together. E.g., potassium iodide and lead nitrate mixed with lead nitrate solution. So I have Ki, which is my potassium iodide, and my lead nitrate. And when they mix together, both of these are solutions, and I end up forming a precipitate. And what happens is they swap places, and the lead now joins with the iodide. I'll actually need two iodides because the lead's 2 plus and iodide's 1 minus, and potassium then joins up with the nitrate. When I'm rewriting this equation, to show that they're in solution, I stick an AQ next to all of those that aren't a precipitate, just to show. No, AQ means dissolved in water. So all of these are AQs. The one that isn't, which I write an S to, is a precipitate, which is a solid. And in this particular case, the precipitate of lead iodide is a very yellow precipitate. So basically a colourless solution plus a colourless solution, add them together and I get this yellow precipitate forming. Now, one of the other things I did want to talk about this week is balancing equations. So if we're balancing equations, we've got to look at the number of ions on each side and just check that they balance, or even more than the number of ions, the number of atoms on each side. So you can start to see here, I've got one potassium here and one potassium here. So that's balanced. I've got one lead, one lead. When we start looking at the iodines, I've got an iodine there, but I've got two iodines there. So that tells me that I'll need to react one of these with two molecules of potassium iodide. So one lead nitrate molecule will react with two potassium iodide molecules. So now I've got two iodines here, two of those and two there. Now with my potassiums, I've got two potassiums now, but I've only got one over there. So I can solve the problem by saying that when I produce my lead iodide, I'm going to produce as well two potassium nitrate molecules. So stick a 2 in front of here, and now it's going to work really well, because if I look at the nitrogens, I've got two nitrogens here, and I've got two nitrogens there. Look at the oxygens, I've got 6 oxygens there, 2 times 3 is 6, and I've got 6 oxygens there, 2 times 3 is 6. So now this equation is perfectly balanced. So there's the same number of atoms on each side. We call this reaction where we swap partners. So in this case, the iodide and the nitrates are swapping places. This swapping ions is called a double displacement reaction. So precipitate reactions are double displacement reactions. Now let's move all of this up. And to visualize it, this is how I would visualize it. So this is a good bit of notes to take. In my first tube, I've got lots of K pluses and I minuses floating around everywhere. In my next tube, I've got lots of PB 2 pluses and NO3 minuses floating around everywhere. When they react together, say it reacts into a big beaker, I'm still going to have the K pluses floating around and the I minuses. And then the lead and the NO3 minuses, they're all going to be all floating around, a bit like at a disco. Everybody's dancing a disco. But then something very interesting happens. These join together and form a precipitate. So they're no longer floating around, they're stuck together, form the precipitate. And the precipitate they form, just you writing PPT, the abbreviation for precipitate is PBI2. So these ions are now not on the dance floor dancing separately, they're stuck together, and that's basically what our precipitate is. There are 3 kinds of precipitate, and we'll just write down what they are on the next slide, which is an important note to take. The first type of precipitate is what we call a crystalline one. And it looks like lots of little crystals. Kind of see the little crystals in it. Our second kind is what we call gelatinous. Looks like jelly. It's often semi-through, often translucent. That kind of means you can half see through it. And our final precipitate is amorphous, which is very solid and there's no distinct features. It looks like one big mass. When you're doing the experiment this week, you might like to think about whether the precipitate you produced was crystalline, gelatinous or amorphous, and practice using those words. You'll not notice as well on the task for this week there's a big table which is very useful that indicates whether precipitates are, which kinds of ions produce which kinds of precipitates. So that's a very useful one. So for example, it'll tell you that barium sulfate is insoluble. So we call this the solubility table, and the potassium chloride is soluble, potassium nitrate soluble, barium nitrate soluble, calcium sulfate's partially insoluble, calcium hydroxide's partially insoluble, potassium sulfate's soluble, silver chloride's insoluble, mercury 1, bromide would be insoluble. So basically look at that table to help you, and look at the other videos, but in particular the first steps video that really explains how to use that table really well. Okay, thank you for listening.